All right. Good afternoon, everybody. Glad to see there's so many people, excited people about networking as I am. Just so many of you guys out there. So thanks for coming out. I'm Nick Matthews. I'm a solutions architect. Been working with the team on Transit Gateway and before that Transit VPCs and all other things. I did a session last year on Transit VPCs, and that was sort of the plan this year, but then we released Transit Gateway, so I had to redo everything. So, I'm super excited about it. Super excited. It's so cool, and we'll get to see why. What to expect from today is first we're going to explain some mechanics of things. So we're going to explain a bit about Transit VPC. Like it or not, we'll actually use some of those pieces again. So, and I had Transit VPC in the title of this, so I don't want to rip you guys off by not talking about Transit VPC at all. So there's a little bit of that in there. Then we'll get into the Transit Gateway mechanics and how it differs and what it works like and that kind of thing. But I mean, the real point of this is to really build out an architecture. So we've released some new features like Transit Gateway and VPC Sharing, and I think it actually dramatically changes the way that we're going to build networks. And so there's a lot of ways you can do that, and I've sort of chosen a reference architecture, and we're going to walk through that and the ways you would modify that, rather than going through like every nook and cranny of all these features, which there's other sessions on that. So the idea here is to give you some sort of actionable advice and a reference architecture that I think we can use that scales both for small and large companies. If we start off, the question is like, why are you even talking about lots of VPCs? Like, what's the problem we're solving here? So VPC is a little bit different than other networking. So on premises, we say that your VPC is like your data center in the cloud. It's this highly segmented sort of network. The difference is you don't create data centers in seconds. If you do, we've got a job for you at Amazon. But you can have 200, 300, 500, 1,000 VPCs. People usually don't have that many data centers. So that sort of logical construct stops making sense at some point. As well as the access model. So a single account has a root access key that gets access to everything. You probably don't have a single credential that gets you into every part of your data center, mostly because organization of that is hard. And then also just the ownership. So there's a lot of line of businesses people, developers, people that have no idea how networking works. They are the owners of a VPC. And so that creates some unique challenges in terms of how you're going to manage and how you're going to scale those VPCs out. So we take a pretty traditional sort of starting point here. We have two VPCs, one for development, one for production. We've connected that either through VPN or direct connect. I have both here. This is pretty manageable. And if this is your environment, this is probably going to be a pretty boring talk for you because this is pretty well understood. But at some point you maybe scale. Maybe the green group joins you and they have a couple more applications, a couple more VPCs. So we've got 6 here, and we start to have more tunnels and more direct connects, but it's still mostly manageable. But then you say, okay, well, how does the actual connectivity work? Because if I want to talk between these VPCs, then I'm going to have to go back on premises, which is not really that awesome. So let's start peering some things. So let's just say that development and production should be peered. All right, so we're going to have sort of 3 peering connections. But let's also say everything in the green area should be able to talk to each other. So we create another 4 peering connections. And so at 6 VPCs, this sort of works. But as you scale up, what does that look like? So let's just say that now the orange group joins us, and the green added a few more things. So we need to add another potentially 6 VPCs with 4 VPN tunnels, another 24 VPN tunnels. At this point, the network engineer on premises is like, what are you guys doing? Stop, please. Like, I can't have this many tunnels. Like, this is not the way we operate. Like, what is going on here? And so then people say, like, how do we solve this? Prior to this week, and I've talked a lot about this, Transit VPC, right? For all of its faults and all of its glories, there's a lot of customers running this. It works. People are using it in production. But we got feedback. They said, look, this thing is complex. It's hard to operate. It's hard to manage. There's parts of it that I don't understand. Not everyone, for example, is a Cisco CLI jockey. They're not super good at managing Cisco routers. Or some people just said, hey, we want it cheaper or better or faster. 90% of the features we build comes from customer feedback. And so people said, we want something easier. We want something better. We'd like a managed service. We don't want to manage instances. And so we listened, we built, and you get AWS Transit Gateway. So it's basically a drop-in for the AWS Transit VPC. To get started, we'll talk about the way that Transit VPC works and some of the mechanics there. Because one, some of you will probably still running Transit VPCs. One of my first jobs I did was troubleshooting fax machines. That wasn't that long ago. People still run fax machines. Things don't go away. We understand that. We still have our original services. So Transit VPC will probably exist for forever, just because that's technology. But we'll also reuse some of these concepts with Transit Gateway. So if we start off with the original Transit VPC design, we have 2 instances down at the bottom. Those could be routers, that could be firewalls. The first one that we released was with the Cisco CSR, so you have some virtual routers running on instances. Those have VPN connections to our virtual private gateway. The virtual private gateway is our managed VPN service. So you don't have to manage any instances, we just terminate the VPN. It does BGP and routing, that kind of stuff. So now, from an availability perspective, we're in 2 availability zones on the bottom. So we've got connectivity to 1 VPC. Not super helpful yet. So we'll create another VPC, and we will create 2 more VPN connections. And so now we've got redundancy, and these will talk BGP. So basically, the traffic between these VPCs will go through the Transit VPC. If you've got something like a firewall there, that means you can do inspection. If you have something like a routing there, or a router, then it's just sort of a side effect of the way this works. And so we advertise those routes to each one. This route table will have a route to the other one. So I've got 10.1 and 10.2 here. So in their route tables, they will see routes for each other. And now they can route through the Transit VPC. And you can scale this out. You could do this to, I don't know, something like 100 VPCs before you really have to start tweaking and tuning it. So pretty scalable method. You could also use this to go out to the internet. So as opposed to just re-advertising the routes you get from the VPCs, you could advertise your own route. Maybe connect the internet to your Transit VPC. You would have to do some source NAT. But now, especially this is like the egress firewall filtering case, or you want all your internet traffic to go out your Transit VPC, you could do that. You just advertise the default route through the virtual private gateway, and you could do that. So it's a pretty flexible architecture. For a lot of people, this is the closest that we can get to a DMZ, like nice, comfy, warmy DMZ that everyone just likes so much. That's a different talk. And so, this it works. But I get some questions. Like one is like, hey, why are you doing IPsec all over the place? Didn't you know you could use peering? It doesn't have any IPsec overhead. It's much faster. Just do that instead. Well, brilliant thought. Let's try it. It doesn't work, by the way. But it illustrates some good things. So, OK, let's do VPC peering between the spokes to the Transit VPC. In the route table of the spoke, the only thing we can create a route to is the peering connection. All right, so we 0, 0, the internet goes to the peering connection. So when the instance in that spoke sends a packet, what's going to happen? It's going to go over the peering connection. It's going to arrive at the Transit VPC. Well, who knows which route table your peering connection's in? There isn't one. There's no route table. So there's no way for us to make a route table decision there. And so roughly, basically, if it comes from the outside and wants to leave outside, it doesn't either start or end on an instance, then we're not going to be able to do any routing there. So doesn't route. So sort of the transitive routing rule is traffic either needs to originate or terminate on a network interface. And I'll say network interface again, network interface in the VPC. Because when we start talking about Transit Gateway, it actually uses network interfaces. So transitive routing starts becoming much more easy. So VPN works because the virtual private gateway terminates onto the instance. And so when the traffic comes in, it comes to the instance. The instance will decapsulate all the IPsec encryption. And then it will re-originate that from another interface or the same interface and go out to the internet. So we've now met our requirement for transitive routing. And we've got mucho bueno, which is Spanish for it routes to the internet. So usually when I show network engineers or pretty much anyone anything, they go, hey, this looks pretty cool. Looks like it might work, but how does it break? Because that's what I'm going to have to deal with once you install this thing. So let's find out. So this link here that's red, I know, lightning strikes it, whatever. Something happens to either the instance or that link or something on our side, sunspots, fry something, doesn't really matter. So because we're using BGP here, or we're also using VPN, the good thing is we're using decades-old technology. So BGP's got keep alives that happen every 10 seconds with a hold down timer of 30 seconds. Inside of VPN, there's a data plane check that happens on our side every 10 seconds with another hold time of 30 seconds. So we should detect this failure hopefully within about 30 seconds. And when that happens, the routes fail over automatically. So we don't have to make any API calls for that to happen, and we're letting routing things do routing things. And so that's one of the benefits here. And so we'll actually reuse this concept of using VPN with the built-in health checks to do additional services with the Transit Gateway. So this is not just dead, gone information. We'll reuse this. So on performance-wise, the Transit VPC, the instances down on the bottom on something like an M4 or C4 instance, just do the packets per second and the way the IPsec's handled on those platforms. No matter which VPN offering you use, is going to get between probably 1 and 3 gigabits per second. So we've now created this thing that does that. The virtual private gateway up top, no matter how many VPN connections you set up to it, no matter what you do with BGP metrics and those kinds of things, it's going to choose exactly one route all the time. And that one route is going to be limited to about 1.25 gigabits per second. And so that means we've got some scaling parameters here that we can't change unless we start moving which instances are in which VPCs, or we use VPC peering to augment some bandwidth, those kinds of things. So it's not a particularly scalable architecture, but again, it meets a lot of customers' requirements because not everyone's got hyperscale requirements. And we'll also use some of these performance characteristics in the Transit Gateway. I talked a little bit about firewalls. The only thing that really changes here is that you probably don't want to send traffic to both simultaneously. Usually there's an active-passive pair because you want to see both flows of TCP. So you do AS path prepending on one of the firewalls to make it the passive, and that way all traffic goes to the active firewall. So Transit Gateway, what is it? How does it work? We built this from customer demand. We built this because on what we've seen, and this is what it looks like. So Transit Gateway is this regional router. The main sort of use case is aggregating your connectivity from on-premises, VPN and Direct Connect. Direct Connect is a roadmap item for us for Q1 next year, so you have to wait a little bit if you want to use native Direct Connect capability. One of the biggest differences here is scale. So AWS, we do scale well. So this scales out to 5,000 VPCs. So we've solved a problem there. You do something about, we have these route tables, which allow you to create policies. You can create 20 of those. On premises, you can connect your VPN there. We do support ECMP, equal cost multipath, which means that we still have that 1.25 limit, but now we can scale horizontally with that limit. And so we've tested the throughput of this Transit Gateway up to 50 gigabits per second. Doesn't mean that that's the highest it goes, it's just that's how many resources we decided to test with, and it worked. And so if you want to go higher than that, you probably should talk to us. And it also increases the flexibility of our routing. Because we're putting network interfaces in each VPC, so for a VPC, we create an attachment. And that attachment shows up as a network interface, which means it also will obey the route table rules in that VPC. It also has these things what we call route domains or route tables. This is basically a route table that defines the policy for multiple VPCs. So if we say, like, these VPCs should only be able to talk to each other, and the shared services VPC and VPN and nothing else, we create a route table for that. If you say these VPCs should only talk to this one resource, you can create a route table for that. And so this allows us to do things like split dev and prod and create some really flexible routing domains, which we'll talk about later. Almost the first thing I always get questions on this, since we've been doing betas and other talks during this week, is like, how does it work? How does it break? Did you guys just put a big router in the cloud? Is that thing going to break? Like, what happens when your router crashes? Am I going to hurt when that happens? And so there's this fundamental understanding of a router's going to break. We didn't do that. Spoiler alert. So we have this platform we started talking about at reInvent last year called Hyperplane. So Hyperplane is a horizontally scalable state management service. And that state management service, in this case, does networking. So we deploy this in a region. It runs on EC2. And we have terabits of capacity on this thing. And so it's a multi-tenant service with terabits of capacity. It's also not brand new. We've been doing this for network load balancer, NFS mounts, NAT gateway, private link, and now Transit Gateway. So if you think about sort of how NAT gateway works and the availability and stability of that, if you think about network load balancer, how it scales up to bandwidth requirements, if you think about the single IP address per availability zone of the network load balancer or the NAT gateway, it inherits a lot of those same capabilities because they all have the same sort of mother platform here. When you create an attachment, that's one per availability zone, so you'll define one subnet per availability zone. If you want to, you can dedicate a whole subnet just for the attachments, depending on how much IP address space you have left over. And it's highly available per availability zone. So whatever you want to use this, you want to put it one AZ per that you're using. So if you're using 3 AZs, you want 3 subnets. Each one of those attachments will get bandwidth that's spread out across that fleet. You can add more and more network interfaces. You get more and more bandwidth across that. If you have other VPCs or other tenants, we just have more things. And so if we notice that maybe you're using a lot of bandwidth, we can scale you up. If we notice that some of these instances have died, a very small percentage of your active fleet goes down. And so, this is how we get a horizontally scalable router without any single points of failure. But the Transit Gateway itself shows up as a regional construct. So you don't have to care about all this cool data plane stuff we're doing in the availability zone. So super neat stuff. It helps answer a lot of hard questions I usually get at the end of sessions. So I decided to just put it up here up first. So let's do some examples. So let's say that I want to do two things. I just want the easy use case. This is like Transit VPC. I just want everything to be able to talk to everything. That's my job as a network person, is making sure everything can talk to everything, and someone else's problem if they can't. So, or I could do the isolated one, where I want to have a little more segmentation, where I want to make sure they all can't talk to each other, but they do need to get back on premises for some reason. So let's go through these examples. And this is actually the default functionality for Transit Gateway, which is sort of this default mode. So we have this route domain here. We attached a VPC, so we define two subnets. We get two network interfaces, which will get IP addresses in that VPC. From there, we will define a static route into the Transit Gateway. Because the Transit Gateway, each route table can support 10,000 routes, but the VPC route table remains unchanged. It supports 100. There is no way to just automatically propagate routes from the Transit Gateway to the VPC route table. And so the way you'll do this is you'll create sort of a summary route, maybe the 10/8 network or the RFC 1918 networks or a 0/0 route to the Transit Gateway, and the Transit Gateway will then make sort of more educated routing decisions past that. As you attach more VPCs, they're going to add their CIDR range into this as an attachment, more VPCs, more attachments. So at this point, they are all in the same route table. Those routes are all there. Then they can all talk to each other. So you have full connectivity, sort of east-west. And I also talk about route domains because I find it simpler when I'm talking to customers about a route domain, making sure that it's clear that that decision has an effect across multiple VPCs. Because sometimes when you say route table, people are thinking a single VPC. And so in the console, it's actually a route table. So it's just more of a talking point than anything else. In this scenario, we've got the isolated scenario where we don't want them to talk to each other, but we do want access over VPN. So we create a separate route table here because we now have two different types of policies. So the VPCs are on one route table. The VPN is attached to another route domain. So we have now a new attachment type, the VPN. In this scenario, the route table will have a 0/0 to the Transit Gateway. We will then put that route saying 0/0 goes to the VPN. We can do static routes or dynamic routes through BGP. We'll only talk BGP at this point. In the route domain for the VPC, for the VPN, we'll put all the route tables for the VPCs, which means now VPN can get to my VPCs. The VPCs have a route to the VPN, but they don't have routes to each other. So that route table connected to the VPCs, they don't have routes to each other, and so they won't have connectivity. So when you attach a VPC, that defines where it's allowed to go. When you propagate a route, that changes who can reach it. So if I say these 4 things should be able to reach me, I want to make sure they have my route. I will propagate my route that way. But where you attach it to that route table defines sort of its access. So in this model, east-west, no bueno, north-south, bueno, we're routing, we got packets. From a quick comparison perspective between Transit VPC and Transit Gateway, Transit VPCs, you're managing the instances, scaling is a little bit difficult. Segmentation is possible with things like VRFs. Not a lot of customers are familiar with the VRF functionality there. So we've made that simpler with a managed service. We're using Elastic Network Interfaces to get away with the transitive routing sort of solutions here. It scales horizontally, and we're making it easier to segment things with route tables. And so that's just a high-level sort of comparison. So Steve Seymour and this session is NET402. They did a sort of deep dive on Transit Gateway. So I've given you enough information now to understand the rest of the presentation. All the other sort of questions you may have about Transit Gateway would either be sort of implicitly part of this presentation or part of that one. Because again, we're going to try to focus on the architectural stuff. Are there any reasons to keep using a Transit VPC? The first question is if it's working for you and you like it, keep on using it. You also may find it useful to use a Transit VPC to migrate to Transit Gateway at some point. We have some slides on that. But otherwise, a lot of the other stuff I see, security, SD-WAN, NAT, proprietary stuff like DMVPN, I firmly believe that Transit Gateway actually makes all those use cases better. And so we'll talk about firewalls, we'll talk about those other use cases, and how you build sort of a new Transit VPC using those services, but Transit Gateway is the underlying sort of architecture. It's also worth calling out here that we're not actually getting rid of any options. So we're not getting rid of things like peering or private link or Transit VPC. Everything you're doing today, you can continue doing. You just have more options with Transit Gateway. So if we start with our architecture here, we have 4 main VPCs. We've got development, test, production, and shared services. You may have some other accounts, so administrative accounts, things like landing zone or security or billing or administrative accounts or the network and infrastructure ownership accounts, but you probably don't actually run instances that need to talk to other things there. And so these usually have some sort of IAM permissions or cross-account roles, those types of things. From there, you'll connect those 4 main VPCs to the Transit Gateway. I chose this over peering and for some reasons like scalability. So if you want to add more later, you use this. But for the moment, and for this architecture, we're using Transit Gateway to connect our 4 VPCs. We'll put some route tables there for segmentation. We'll then connect on-premises through VPN and Direct Connect. And then there's this concept of, hey, if I've got all this flexible control with route tables, can I centralize my internet, either egress or ingress? Because we get a lot of customers that want to do that sort of thing. Because the internet's scary to, for security people. And so can we put some more control around that? And so we can do outbound services VPC. We can do an inbound services VPC for inbound services. Or if we want to put sort of an edge in front of our network so that it looks more like something else. Or if we want to do this inline inspection, either between our VPCs or between maybe on-premises and our VPCs here. And so we're going to walk through, 1, what's in this thing, 2, how would you change it up for your scenarios, and 3, sort of how it works. So when I talk to customers about these types of things, this is typically how I lay down the platform, right? We talk about the account strategy. Then we figure out how we're going to segment those things. What are our segmentation requirements? How do we want to do shared services? How's that going to work? Connectivity to on-premises, there's a bunch of options there. And then any sort of additional network services, some of those things we were just talking about. And then multi-region connectivity. And so we're going to try to address all of that. Well, we are going to address all that today. So let's get going. So on the account strategy side of things, we've got 2 sort of main options historically. So we've got this concept of I've got a very big account, a very big VPC, or lots and lots of accounts and infrastructure. And so you're like either get really good at IAM and security groups, or you have just lots of VPCs. And our customers have said, why can't I have both? Like I want granular control, but not with a lot of infrastructure. And so yesterday we released VPC Sharing. So the concept here is you can have an infrastructure account, and then maybe some tenant accounts. In the infrastructure account, we have to maybe help multiple types of accounts. So we've got these folks that want to create external applications, these folks that want to do internal applications, and we want to provide the infrastructure for them. So in this model, we create a VPC, we define the CIDR range, we go and create public subnets, private subnets, internet gateway, connectivity on-premises, route tables, all the networking sort of scaffolding here. And then we create shares with the resource access manager. So we create a share here with the public and private subnets and share it to the external accounts. We create a separate share with the private subnets and share it to the internal accounts. And so now they don't have to worry about setting those things up. We can control what they have access to, and now we get different accounts in the same VPC. If you actually look at, as the owner of one of those accounts, and we take a look, if this red account deploys some instances, 1, they only see the public and private subnets. They don't see the VPC or anything else. They'll see only their instances. They've got control over their account, their security groups, their data, their configuration, all those kinds of things. This green account, which only has internal, will only see those subnets, will only see their resources. And so this makes it a really, really strong story for separation of duties. So if you have an infrastructure team that wants to set this up and make sure that the sort of developers or people developing things don't have to worry about networking, so you can take that away. It's also a stronger control mechanism if you don't want them messing with route tables and doing something like accidentally opening up internet to something they shouldn't. And so it's a very strong control policy here. Also, it's good from a resource utilization So less wasted VPNs because you've got less VPCs, better use of your address space because now multiple people can fit in sort of the same swimming pool of IP addresses. And also, I think this is probably the most important, but just decoupling an account and the network. And so if you want to have an account per developer, you can do that. And you don't have to have a VPC per developer, which is probably an unintended side effect. Also, if you've got maybe like your web group in one VPC and your database in another group, and you've done VPC peering between those because maybe billing needs to be separate or something, you're paying VPC peering charges for that. You put them in the same VPC in the same availability zone, there's not going to be an additional charge for that. So you actually might use this to save money as well. So some things you want to think about is, one, this may not fit for every use case. So for example, you may say for production, it's easier to put them in separate VPCs rather than do the sharing concept. If you want to have lots of VPCs, we can do that now with Transit Gateway. This also only works with an organization because there's some trust considerations as part of VPC sharing. And it also doesn't do any sort of resource allocation. So if one of the tenants or one of the accounts wants to use all the IP addresses that they've got access to, there's no real way for you to stop that. Or if they want to use, for example, there's a limited amount of like network load balancers and endpoints you can create in a VPC. And so that's shared across all of the accounts. And so we haven't fundamentally changed the VPC limits. And so as the sort of owner of this infrastructure account, you would need to also do sort of resource and capacity planning. And so that may impact the way that you use this feature. So the next step here is really about segmentation. So, okay, we have some accounts, we've done some, sharing, but how do we actually protect this? So, and this is the place where AWS is, going to have a much harder time about giving you direct guidance on because, every organization I talk to seems to have a different sort of policy or way they've sort of split this up. So what's the relationship with accounts? Are you a provider and like one of your VPCs, another one of your VPCs are direct competitors and they just frothy hatred is there? Like, you don't want to put them in the same VPC. Like, just don't do that. Separate VPCs. But if there's like two different development groups and they like each other and so that sort of relationship is important, depending upon what segmentation model you're going to choose. Also, is it centralized? Like, do you just have a whole bunch of people developing stuff and there's not like a strong infrastructure group? That's going to depend on how you do this as well. And also just scope and governance. So, for example, if you have a PCI application, it's probably going to be easier to put that in a separate VPC rather than try to convince your PCI auditor that this is also just as good. If that saves you time, that's probably a good idea. So if we start off with some accounts, let's look at some of the options and layers we can do for segmentation. So inside the account, nothing's changed. IAM, security groups, your best friend, use them, right? Security groups, and it's worth stating that nothing can talk to your instance until you've whitelisted it with a security group, right? So just because you've put two instances in the same VPC doesn't mean they can talk to each other. Security groups still block that until you whitelist it. And same thing with IAM and sort of policy-based things. At the VPC level, we still have good old route tables, letting us know what can go to the internet, what can't, that type of thing. Inside the VPC, we can use network ACLs if we want to sort of mimic some functionality. I'll show you how to do that. You can do separate VPCs, tried and proven. We know how that works, and now with Transit Gateway, we can support that better. You also may want to think about this sort of, I've seen this inside companies where the people that are owning the accounts and the people that are sort of responsible for setting up the accounts have this sort of implicit shared security line. Like, if you can't guarantee the developers will do the right security groups and the right IAM policies, if that's just not part of your organizational discipline, then sometimes it comes down to like the infrastructure team to do that for them, which is not an optimal model because if you own the application, you should own the security as well. That's how like AWS thinks. But we realize that's an organizational and operational change that's not necessarily trivial, and so that's why we've got multiple layers. If we go further down the stack, we've got the Transit Gateway. So the Transit Gateway, you can use the route tables to do further segmentation between your networks. And then if you really want to, you can throw inline appliances, your next-gen firewalls, intrusion detection. If you have some compliance requirements for that, that's yet another layer. If you want to do the network ACL example, we'll do this. So we have our VPC. We have both red and purple people, and they should never talk to each other, but we don't want to put them in separate VPCs for some reason. So we want to mimic the VPC functionality. So what we'll do here is we want to make sure they can't talk to each other, but they can talk within their own subnets. So a network ACL example is this, where we whitelist the two subnets they are in. we would blacklist the rest of the VPC, and then we would allow everything else so they can go to on-premises or the internet. And so like, you have to be careful with this because network ACLs are, one, easy to mess up because they're stateless. Two, they're easy to forget because they're not quite as visible as security groups. So if you have strong operational practices around this, it's a good idea, but for one-offs, it can be, it can just bite you later sometimes. Because if you add a third or fourth subnet here and you forget to add the ACL there, or if you don't associate the ACL to the right route table and that kind of thing, it can get a little challenging. So if we take a look at the Transit Gateway, what we can do there, this is the example we did before, where we put everything in the same VPC. If you said, hey, we're going to use security groups, they're strong, and I'm just going to provide access to everything, security groups will be my sort of control. Super simple, right? You don't have to do anything with Transit Gateway. If you want to do something a little bit maybe more involved here, we've got 3 VPCs, dev, test, production, as well as a shared services VPC. We don't want dev, test, prod to talk to each other. Everything should be able to reach the shared services VPC and VPN. And so the way we do is we create 2 route tables here. The VPC route table has access to VPN and shared service. The VPN has access to all the VPCs. And so that means that we don't have east-west there. We can talk to shared services as well as to the VPN. And so we can use this fairly flexibly. And you can mix and match this as well based upon your requirements. So it's just some thoughts of where to start. Again, because we have all these networking controls, it's tempting to say like, oh, well, we don't need security groups anymore. We'll just let the developers do whatever they want. Like, security groups are still a very, very strong control. Like, the more you can monitor those and the more that you can provide the best practices for them to do that, the less, sort of dependencies they have on the networking team. Shared VPCs, think about the resource sharing as well as, if you're peering 2 VPCs, there's a pretty strong case in my mind that those should just be in the same VPC. And you can see what that looks like in your organization. So in this model, like, I have not talked about virtual private gateways or peering yet, right? So in theory, you don't actually need those in this reference architecture. Separate VPCs, we can get philosophical about security, but quite simply, simple things work. And we do a lot of things that are very simple. And so if separate VPCs are simpler for you, just because my architecture has shared VPCs, don't take that as gospel, right? Do what's right for you. If it's simple, work it, right? And use the Transit Gateway for sort of multi-VPC policy. All right, so shared services VPCs. Let's get into this. So we did a lot of chalk talks and stuff like that this week, and this came up quite a bit. Like, we have a lot of options. We can do VPC peering. This is sort of the canonical example of what people do with shared services VPCs. You put your logging, monitoring, authentication, things like that, AD, in one VPC, do VPC peering to all of your other VPCs. That works until you get to 100. And it's pretty strong, it works. You can reference security groups across VPCs. So right now, VPC peering is the only feature that has that. So if you need to reference a security group across VPCs, VPC peering is still your right answer. We've got Private Link. Private Link is a different model. Private Link is a per application share, and it's also more secure because it has a stronger sort of model of the trust boundary, because you can only go from the client to server, and because you have to do the two-way authentication, and it's for a single application, it's just more granular than the other options. And so if you want a granular account policy, or if there's trust sort of concerns between the two VPCs, then Private Link is probably a better model. We've got Transit VPC. You can do a shared services VPC through the Transit VPC. You just make it as another spoke. I presented on that last year. It still works, but you've got all the management involved. Or you've got Transit Gateway. So Transit Gateway, again, is your sort of multi-VPC strategy for allowing access to shared services. So if you want to do more than 100 VPCs for peering, or instead of peering, you can do it with Transit Gateway. So effectively, we've gone past the 100 peering limit with Transit Gateway. The ones that scale are here, Private Link and Transit Gateway. So that's what we'll talk about. So in this model with Transit Gateway, you can put your shared services VPC there. You can connect it to the rest. This is fairly simple. The reason why we chose Transit Gateway here over peering for just 4 VPCs is because, one, we have a little more control over the isolation models with the route tables. As well, if you acquire another company and they have 400 VPCs and you want to access them to your shared services VPC, your peering model is just broke. And so depending upon what your future looks like, this gives you more flexibility going forward. If we compare Transit Gateway with Private Link, again, Private Link, the scope is on a per application model. The trust model, there's no real mutual trust between the two. So that's a benefit. But it also doesn't really require think about too much unless you have to have that load balancing. So if it's a service that can't be load balanced, it's sort of off the table for private link. But Transit Gateway, like we've shown, it's on a per VPC or sets of VPCs. But you do need that sort of who's going to manage the Transit Gateway. So you want someone in your organization that will sort of own that. And so private links also for like a lot of microservices or for SaaS services. Transit Gateways, from my guess, will be mostly within the same organization, although it doesn't necessarily have to be. All right, so let's connect on premises. What does that look like? So VPN and Direct Connect. Let's dig into some of those details. So if you want to connect on premises, a couple options. You could do our VGW. You can do Direct Connect. Pretty well understood. 1.25 gigs, and then there's no real bandwidth limit on Direct Connect other than your port speed. You can do Transit VPC, which, again, you can do it. It works. A little bit of complexity, but it gives you that one-to-many functionality. Or you can use Transit Gateway. So the ones that scale here are Direct Connect and Transit Gateway. So that's the ones we're going to look at. So Direct Connect works like this. We've got points of presence all over the place. I forget the exact number. It's, I think, 80-something points of presence across the world. You find the closest one to you, and then you get connectivity to that router. You rent a port from us, anywhere from 50 megabits per second to 10 gigabits per second. And from there, you create a virtual interface into your VPCs. So in this model, you create a private virtual interface that gives you direct connectivity to each one of these VPCs. In this model, we would have 2. Now, because we just ran cable to a building, and that goes into our backbone, we would like for that to be highly available, so we choose a different location, get another router, and do 2 more private virtual interfaces. So for a single region, this is sort of, with less than 50 VPCs, this model is sort of the way you look at that. If you want more than that, you can do a couple things. You can do link aggregation. So instead of doing one link between your router and our router, you can do multiple. Each one of those links gets you an additional 50 VPCs. So at the default limit of 4, that gets you up to 200 VPCs. Especially if you combine it with VPC sharing, that probably buys you some additional space. You can also do Direct Connect Gateway. So if you have multiple VPCs in the same account, you can actually get some scaling advantages here. So you can create a Direct Connect Gateway, associate the virtual private gateways to that Direct Connect Gateway, and that gives you a single VIF per account. And so then, as long as you have less than 10 VPCs in each account, you can have one VIF per account with Direct Connect Gateway. And we'll talk about how Direct Connect Gateway is also used in multi-region connectivity later. With Transit Gateway, if you want to use it with Direct Connect today, you've got a couple options. One is, like I said, we haven't taken anything away. So you can create private virtual interfaces into Direct Connect and use Transit Gateway for other things. You do want to keep track of the static versus dynamic routing here. But this can work, especially if you already got Direct Connect deployed. You can do VPN over a public virtual interface. So the way this works is there's Transit Gateway. Surprise, surprise, it lives within AWS. So all the IP addresses for Transit Gateway are ours, right? So when you get a Direct Connect and you get a public virtual interface, then we will advertise all of our public addresses to you. And so when you get all those public addresses, you can then create a VPN to our Transit Gateway, and that will go over the Direct Connect. And so this also happens to get you encryption in transit in case you wanted to do that kind of thing. And if you have something like a 10 gig Direct Connect, you would create something like 8 to 10 VPN tunnels over us. Or not, if you're not using the whole tunnel, you don't have to use the whole thing. But you can encrypt, like, for example, a 10 gig Direct Connect using this model. Otherwise, we'll have this Q1, so you don't have to go hack stuff together if you don't want to. And we'll have something hopefully for you Q1. Otherwise, and this is maybe the case if you already have an existing Transit VPC, or if you really, really want a private VIF now, you could do something like this, where you create a Transit Gateway, attach VPCs, create a Transit VPC, add the Transit Gateway as a spoke to your VPC, your Transit VPC. You have your Direct Connect into the Transit VPC, and then you create tunnels over that. And so if you already have an existing Transit VPC, it already may look like this. And so the real difference is, and this is also how you might do migration, you take the spokes away from the Transit VPC, put the spokes on the Transit Gateway, and then connect the Transit Gateway to the Transit VPCs via VPN. And so this is actually useful for, this model is useful for a number of things. One is if you want to maybe connect firewalls to AWS, so the Transit VPC would be firewalls. If you want to do something like SD-WAN into AWS, these Transit VPCs would be sort of an ingress edge. If you want to migrate off Transit VPCs, you can use this model. If you want to use a private virtual interface before we launch something in Q1, this is another way to do that. I told you we were going to use more Transit VPC stuff. All right, so VPN, how does VPN work? So we actually took the core functionality from the VGW into the transit gateway, so all those things basically look the same. From an encryption perspective, it's also the same. So even though we've drawn this box outside your VPCs, because the network interfaces are in your VPCs, I've been using this phrase, but essentially the router is like an omniscient being in all your VPCs simultaneously. So it's not like your VPN encryption still happens at the edge of your VPC. And so from an encryption perspective, we haven't changed anything from the virtual private gateway. We've just changed the way it sort of looks in the console, essentially. If we want to add more bandwidth, this is where we do ECMP. So we've tested up to 50 gigabits per bandwidth. So if we want more bandwidth, we add more tunnels. And so that's pretty straightforward. On premises, you want to check your equipment. Not all equipment on premises can do that. For example, like firewalls typically don't have quite the scale that routers do. They might be limited to 3 or 4 tunnels as opposed to 100 or something. So you may want to check your configuration. It's only over multipath BGP as well. So, all right, I said this is better than Transit VPC, but we can make it better. So let's go through an exercise real quick. Let's build Transit VPC with Transit Gateway. We have a couple of VPCs, create a Transit Gateway, create a route table, create the attachments, create the Transit VPC, create a route table for the Transit VPC, propagate those routes, create VPN to there, propagate that VPN to the other route table, and then we will add route tables here that have a 10/8. So we're going to go east-west between these, like our original example between 10.1 and 10.2. So we just do a 10/8 to the Transit Gateway. Transit Gateway will have a 10/8 back to the Transit Gateway, and maybe a default route to the Internet Gateway so it could do VPN. And we will do active-passive again, just because that's what I showed you before. And so we've now recreated Transit VPC 1.1. All right? Pretty cool. Why would you want to do this? Like, Nick, that just took you like 12 steps. Like, I thought we got out of this. So why are we putting back in this? So why are we doing this? I also just really wanted to put this picture in there. For network services, so if you want external services, we're going to use these same sort of patterns to do this. So in our architecture, if you want to do the ingress or the egress or the inline services, we're going to use that same VPN model to accomplish that. So do I need to put them all in separate VPCs? No, not necessarily, but it's easier to explain it like this, and then if you know the routing and that kind of thing, you can combine them later. So in this case, I've redrawn that same Transit VPC example, but now I've said, hey, I want to do maybe egress filtering out to the internet. I want to do URL whitelisting, or put a proxy there, or firewall, intrusion detection, something like that. And so what we'll do is we'll put 2 instances there. We will do VPNs, and then instead of a 10/8 route, we've now added a 0/0 route. But because, remember that our VPNs are ECMP, which means we can spread traffic over multiple links, we're no longer limited to 2 devices. So we can put a 3rd device here, or a 4th, or a 5th, or a 6th, or a 50th. And so we've now created a horizontally scalable outbound service. And so what we would do here is, on the way out to the internet, we would apply source NAT at these instances or proxies or whatever they are. And so now we can have 5,000 VPCs using a horizontally scalable outbound proxy service out to the internet. Pretty cool, huh? And we're using all this sort of Transit VPC stuff. And all we've really done is we've advertised a default route via BGP to the VPC route table. And so we've got ECMP, we're doing source NAT. Pretty neat stuff. So a couple design notes here is, one, that instance needs to support BGP, VPN, and NAT. So most firewalls and those kinds of things can do that. You've also got performance. So there's no cumulative performance there, but each one of those tunnels is 1.25, so you probably want to size those instances correctly. From a high availability perspective, BGP and dead peer detection are still doing our checks for us. So if one of those instances or links fails, they're going to stop advertising the route, and they get pulled from that route table. We don't have to do any API calls. So that's super nice. And so if you're using any sort of stateful services through this model, just to note that the return and the flow back aren't guaranteed to take the same hash. And so if you need that, then we need to apply source NAT. Or if you're going out of the internet from that VPC, you need source NAT as well. So horizontally scalable design pattern. It takes a little bit of setup, but it doesn't look that much different than what we did today, and it's actually better than what we were doing before. Well, what happens if something doesn't support those things? What does it look like? So what happens if we create this outbound services VPC, but instead of using VPN, we use a VPC attachment? So what we do here is we create a separate subnet for attachments in this outbound VPC. We create the attachments and put those network interfaces there. In the subnets for those network interfaces, we create a route, a default route. So we'll have, in this case, 3 route tables. They each point to a network interface of one of these devices. These also, for example, could be NAT gateways if you want to centralize your NAT outbound. And so it's the same model. And so now we're using routing and network interfaces instead of VPN and BGP. So what do we have to think about here? So there's some red and green on this. Green is there's no overhead. So we've got 8,500 MTU, so we can get pretty big packets. We're not doing VPN anymore, so our instances don't need to support very many things. But we've lost our health checks. So we need to monitor those routes to those instances to make sure they stay up. And as well, we've lost ECMP. So we're actually, if traffic in the transit gateway flow, if we can keep it in the same availability zone, we will. And so that actually breaks ECMP, which means that we're going to selectively try to keep things in this AZ so that you don't get new AZ dependencies without sort of understanding it. So a couple things to think about, right? It's simpler, but you take on some sort of other caveats that you have to manage. So I expect customers to do both. I like the VPN method just because there's less caveats I have to worry about. If you want to do ingress, it looks something like this, where you ingress internet. You have the same sort of service here. We're going to use VPN again because, like I said, I like it more. And so this is like, they'll advertise their local IP address because we're going to apply source NAT here. And so this is more like ingress WAF, ingress load balancing, those types of things. You might have an ELB in front of these services, for example, to do that, or use Route 53 or even Global Accelerator if you want to. Or if you say, hey, I want to put an extraction layer in front of my transit gateway so it looks like an SD-WAN device, or my network engineers want to log into a router, but then I want it from there just to be all AWS. And so in that model, what you do here is you would create tunnels probably from on-premises. You would change the default route out here to the internet, and then do tunnels there, probably do BGP or something similar, so it could re-advertise to the transit gateway. And so now you can create sort of an SD-WAN edge, you can create a Cisco edge, a firewall edge, whatever sort of thing you want to do. And so this is pretty cool, and we're working with the partners to actually formalize these architectures. I'll show you who we're working with in a little bit. If you don't need stateful services, you can turn off the source NAT there. Cool little thing. And so before we get into the firewall section, just a little philosophy for you. So just because we can put firewalls there, and just because we can actually take and lift and shift your DMZ into AWS, doesn't mean it's a good idea. Like, could you, should you? Different things, potentially. I have pretty strong feelings that there's a lot of developers that came to AWS because the DMZ was built that way. Like, if it takes 3 weeks or 4 weeks for on-premises changes to happen for a developer to get a port opened, and you've lift and shifted that stack and that operations, and so when they open a port, they have to wait for that service queue ticket to go through the 6-week waiting time for the ports, you've now just created a problem in a different place. And so let's think very, very carefully before they do these things, and that like the automation is super important, the operations is super important, and any sort of alternatives like cloud alternatives, like looking at guard duty and security groups and go to the security track. They have a very strong opinion on these things. But just because firewalls, we can do this now, doesn't mean it's necessarily an awesome option. It could be. We'll find out. So if you want to do inspection between 2 VPCs, it would look like something like this. We have our transit VPC to the right. We do VPN. We make sure that the transit VPC has a return route back to the transit gateway. We will apply a BGP prefix here for a 0/0, and we'll do source NAT. So this means between VPC A and VPC B, with this route table information, all the traffic goes to the firewalls. And it goes to the same firewall on the way back because we're applying source NAT. So in the spoke VPC, we do actually need the return route to the transit VPC because we're applying source NAT. So one thing to think about here is that the inline, the firewalls, they will see the true source and destination. But in the VPCs themselves, they'll see traffic coming from the firewall. And so if you do security groups and that kind of stuff, you'd have to make sure that they allow access from the firewall. VPC flow logs also works with Transit Gateway. So if you want to use those as part of this, you can do that for visibility. If you want to do something like north-south, how do we do that? So we create VPN. We attach it to this route table. It's the same route table we're using for our VPCs, actually, because they have the exact same policy. Whether it comes from VPC or it comes from VPN, we want to send it all to the firewall. If it comes from the firewall, it can go wherever it wants because firewalls have hopefully made the right security decision. And so in this model, we put the VPN routes into the route table for the firewalls. We put the VPC route tables there for the firewalls. And we apply source NAT again, because NAT solves every single problem we ever want to solve. I love NAT so much. But you can do this, it works. A couple things to think about here is, this is for VPC to VPC and for north-south inspection, just the way I've done this route table. And you may also want to think about, if you're doing this model, you may just want to terminate those VPNs from on-premises directly on the firewalls themselves. And so you simplify the routing a little bit. Just depends on how you want to set that up. Because our stuff is horizontally scalable. In theory, the firewall services here are also horizontally scalable, because we're using ECMP VPN again. So, man, I really hope you guys are getting all this. This is dense stuff. I know you're probably going to have to watch this again to get all because the route tables, a lot of these route tables are here for, sort of reference and stuff. Which brings me to sort of my next point, which is hopefully you all don't have to configure this all yourselves. We're working with our partners to formalize this. So, and for example, for the Transit VPC, we worked with Cisco to create the Lambda function to do a bunch of things so you don't have to do Cisco command lines. I fully expect we're going to see the same types of integrations with these partners that we're working with. So for the sort of 3 major use cases I've outlined here, for the outbound, the edge services, and inline services, we've worked with this group of partners and some more that are on the way as well. And we've also added here a couple of management partners, so like Aviatrix and Terraform are available to do like Transit Gateway orchestration and management and visibility and those kinds of things. We do have CloudFormation support at launch with Transit Gateway. Yippee, little wins, big wins. We also have Terraform at launch. Yay, the other guys. So we've worked with all these folks to make sure that they understand the way this works and that their services will be integrated if you want to do some of the optional network services for ingress, egress, inspection kind of use cases. I want to take a look at a couple of those specifically. So Aviatrix, they're probably more well-known for actually solving Transit VPC. And so we've worked with them to make sure that when we release this product, that their service will be compatible and they can provide value on top of what we provide. So I'm super pumped about this. So they've got an orchestration tool that says, like, hey, if you didn't understand all that route table and propagation attachment stuff that Nick was talking about, that you can have a GUI to do that. And if you want to manage that and make sure that the configuration's the right way, as well, like some of the more advanced architectures, they can automate like the connection to a private VIF over Direct Connect. So I'm a big fan of this solution here. I've also been working with Checkpoint. So Checkpoint has created that horizontally auto-scaling solution. So in this scenario, if you want to do inspection between 2 VPCs, you can put the CloudGuard solution there, and they've got the auto-scaling solution. I believe it's GA ready today. Or early or very close. So we've been working for a couple months on that. And so this gives you that sort of functionality without having to worry about it because it's all going to be automated for you. And sort of more exciting for me is we were working with Xero. So Xero is a company out of New Zealand. They've been on AWS for since 2015 or so. They did a big migration in 2016. And they needed this, what they call the TPZ, or the Threat Protection Zone. So they need to do ingress filtering. They were using some Imperva stuff. They also had to do inspection between devices. And so they built this sort of VPC a while back. And they've been asking us since, like, how can we make this better? And until Transit Gateway, we didn't have a great option. So what they were doing is they were doing explicit proxies on all their instances. And then inside that VPC, they were doing some more static routing there. So again, they were having to maintain all that availability. And so since then, they've grown a lot, and this has gotten more painful for them. And so we were in early conversations with Xero and Checkpoint, and we came up with a design like this. So we built a dedicated threat protection zone for ingress using the Imperva stuff. That goes into the Transit Gateway to all their VPCs. We built a dedicated outbound VPC using the auto-scaling Checkpoint solution. And so that gives them the inspection for outbound. And so now we're using dynamic routing. We've gotten rid of the explicit proxies, and they're pretty excited about the functionality for Transit Gateway here and what that's going to look like going forward. So it's great to have a customer use case, especially coming straight out of beta like this. If you want to connect multiple regions, we've got a couple options here. One is the simplest thing we have, which is cross-region peering. This is one of my favorite slides. All the other slides took a lot of work. This feature is so simple. It's just a single line. We can do peering across regions. We don't do security groups across regions, so think about that. But cross-region peering always goes across our backbone, and it's always encrypted. So security people should be happy about that. So it's a strong feature there. I promise you Direct Connect Gateway details. So if, again, you want to access, maybe you've got a Direct Connect point of presence in Virginia, but hey, we would really like to ride AWS's backbone all the way to Germany. Can we do that? Answer is yes. Create a Direct Connect Gateway, attach it to the virtual private gateway in Germany, and then create a virtual interface from Dallas to the Direct Connect Gateway. And so you can go multi-region with Direct Connect Gateway. That's the sort of secondary feature for it. And so for all intents and purposes, the Direct Connect Gateway is a better attachment model than the Direct VIF. And so we recommend, and the Direct Connect team recommends, to use the Direct Connect Gateway for all VIFs going forward. There's really no downside compared to the existing private virtual interface. We don't know what the Direct Connect integration with Transit Gateway will look like yet, but based on my little tips on this, it will likely include Direct Connect Gateway. So that feature's still in development, so it's not worth prospecting too much here. If you have Transit Gateway in multiple regions, you have a couple options here. You could reuse the Transit VPC, do some VPN between both sides. Now, if you do BGP here, yes, it might be nice to propagate routes around the world. Every time I see a global outage, I'm like, where's the little, show me how it happened, because I bet it's BGP. Is it BGP? Is it BGP? Yes, it was BGP. BGP's best feature is it creates the best global outages. So be careful about this. We've been very, 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 very careful about how we share state between regions so that we don't have global outages. So it'd be a real shame if you just ignored our advice and created a global outage on our platform. So be careful with BGP here, but you can do it if you want. I would personally use a little bit of static routing here just to prevent that. The other use case is like, hey, if you don't have that many global requirements, if you just need to go from one place to another, and it's like synchronization or those kinds of things, cross-region peering still exists and it works, or you can wait for next year sometime. We'll have cross-region coming natively. And that will probably use the cross-region peering, it'll be encrypted, and so we get those nice security benefits as well. So what sort of advice, what sort of conclusions do I have for you? One is, I think the thing that excites me the most about a combination of VPC sharing and Transit Gateway and some of these other features we've done is that we finally have a network architecture that I can go and talk to customers about whether you have 2 VPCs or 2,000. Right? So we've created this scalable architecture, and yes, we might have to do a little bit of wiggle room for your segmentation, your security requirements, and those types of things. And so I hope there's enough advice in here and detail to help you make those decisions. But I'm really happy that we don't have to sort of handcraft every VPC and every network architecture, because I've created something like 150 different network designs. And I think the exciting part is we don't have to do that anymore. And we can also meet additional scale and security requirements that we couldn't really do before. Advice from just me talking to people and things I've seen, what I know about AWS is, I've been a network engineer for a while. I don't know if I'm still a network engineer or not, but I do know that there's a lot of hardware decisions you have to make where you're like, do I get the Model 4 or the Model 12 or the Model 6 or the 6X? Because what is my network bandwidth going to look like 7 years from now? Like I have to buy some hardware for it, and we deprecate our hardware after 7 years. So I need to figure out what my organization's total network things will be 5 years from now. Otherwise, we'll have to buy more, and I'll look bad. And so typically, you buy bigger than you need, so you don't look bad. But you don't have to do that on AWS. Last year, I had this exact same slide, and I said, we're going to mess up your network architecture within 9 months to 12 months. And so I'm so happy that we did that. And I don't know if we're going to do that again, but it's likely. So 9 months to 12 months from now, I might be up here talking about some other architecture, being like, oh, all that stuff's wrong now. It doesn't scale. I don't think I'm going to say that, by the way. But because we have this complexity, because Transit Gateway has all these options, my recommendation is to start simple, and if you can, stay simple, because that's going to really benefit you going forward. Segment and modify this as needed. So if you have some part of your network that does have more complex requirements, maybe you just scope it out. Just say, like, look, if we need firewalls in the PCI environment, OK, just put them there, but maybe not everywhere. Or if we have like strong resource construction areas over here, if we know that someone's going to be using a lot of Lambda in their VPC, like, let's just give them their own VPC for Lambda. And that way they don't mess up everyone else's IP addresses and that kind of thing. And so take the hard problems and try to scope them down and move them off and keep everything else fairly simple. I've seen that used successfully a lot of times. And also test this stuff out, experiment it. I'm really, really hoping that you guys do some cool stuff with Transit Gateway that we didn't even think was possible. I have a couple ideas that I didn't put on here because I already had 92 slides. But I think there's some really awesome things we can do. And so test this stuff out, play with it, come talk to us if you find anything. And yeah, and thank you everybody for coming. Super excited. And I'll be up here taking questions at the stage. Please do fill out the evaluations. We read all those things. I read every single one. So thank you.